Hi, everyone, and welcome to Valley of Depth, a podcast from Archaea Media. Archaea builds media brands around the critical technologies shaping national security. We do this through Payload, which covers the space industry, Ignition, which covers nuclear energy, and Tectonic, focused on defense tech, through journalism, events, and original research. With Valley of Depth, we're going deeper, talking to founders, investors, policymakers, and military leaders who are building and shaping some of the most complex and consequential technologies in the world. Today, I'm joined by Jeff Thornburg, founder and CEO of Portal Space Systems, a company building a new class of spacecraft designed for high-agility maneuvering in orbit. Before Portal, Jeff most notably led propulsion engineering at SpaceX, where he helped develop the Raptor engine that powers Starship. He's also held senior roles at Stratolaunch, Amazon Kuiper, and Commonwealth Fusion. In this conversation, we talk about Jeff's early days at SpaceX, the future of mobility in space, why maneuverability is becoming a strategic priority, the origins of Portal's propulsion systems, and much, much more. Before we dive into today's episode, a quick word about Payload Pro, our premium subscription for deep dive space industry insights, analysis on trends, and exclusive research you won't find anywhere else. Each week, we go beyond the headlines with original reporting, investor perspectives, and detailed financial models. Recent topics include SpaceX's projected 2025 financials, Kuiper's business economics, and the resurgence of satellite manufacturing. We also just published our first report, The Case for Space, a 50-page investor's guide to the space economy. If you're in the business of space or just want to understand it like an insider, subscribe now at pro.payloadspace.com. That's pro.payloadspace.com. Jeff, you've spent a fairly significant part of your career in propulsion and figuring out how to make engines go farther and faster. Tell us a little bit about what kind of drew you to that career from the get-go.
Yeah, so I told a longer version of the story, but my family had acquired some science yearbooks because this was pre-internet, and I became enamored with the sections that were the space program, and specifically, Mercury, Gemini, Apollo, the Saturn V, and then, building on that, my parents took my sister and I to Disney World when we were young, middle school age. And I asked my mom and dad, I said, hey, can we stop by Marshall Space Flight Center in Huntsville and Cape Canaveral? Because I'd love to see the rockets and all of that stuff. And we were just, finally getting the shuttle program going again. And I watched that as a kid. And so, just seeing all of that hardware, seeing those big engines, being the stereotypical fan of Star Trek and Scotty from Star Trek, and the whole limitation of our exploration due to propulsion. I think all of the early day stuff as a kid combined with the reality that we really couldn't make Star Trek happen if we didn't innovate the engines that we use to push humanity around is really what drew me into wanting to be a part of the propulsion in my career. And I think ultimately I specialized in rocket propulsion and aerodynamics in my graduate degree, and then got to work at the rocket site while still an active duty officer out at the Air Force Research Lab at Edwards, and got to work on cutting edge liquid rocket engine technology, which was all of the things that I wanted to do.
Important follow-up question here. So you're a Star Trek guy, not a Star Wars guy, it sounds like.
Oh, I'm bilingual, but I probably have a slight preference for Star Trek than Star Wars, especially since Disney has taken it over. But I'm a somewhat equal fan of both.
Okay, amazing. Okay, I do want to know. So, was there kind of like a single moment in your career, in your childhood, where you said, this is what I'm meant to do?
Yeah, I think so. I think it was after that summer trip to NASA's Huntsville Marshall Space Flight Center, because I got to go. I couldn't afford to go to space camp as a kid, right? That was a pretty tall lift, but I got to go by there and experience that, and then I got to go experience the tours of the launch pads 39A and B at the Cape, and I think that kind of cemented the whole thing for me, and ended up leading me to the Air Force to start my career, but always having an eye to wanting to work on the space side of things. But I think because my parents humored me on the way to Disney World that year, I think that was probably kind of the defining thing. And then I just couldn't get it out of my head anymore. And I always was a kid that loved math and science in school, and I had great teachers that encouraged that stuff. So I probably that summer trip is probably the answer.
So, well, we're going to talk about your time at SpaceX because you did some pretty cool things there. But before we jump to that, I want to ask a more general question. So, you spent a lot of time building propulsion technology. You're alluding to, when you talk about the shuttle, and obviously we've been doing this for a very long time. Why is building and rocket engines still so difficult? What is the most misunderstood thing about designing rocket engines? And it's funny. I've been asked that question before because there are all these, there are obviously the field of launch companies is much smaller than there was even 3 or 4 years ago. But the question is always like, you have a lot of these well-funded companies, good technical teams, lots of capital, but still really, really hard. And there's a global problem, right? Not just the U.S. It's obviously not a U.S. Only problem, but give me your perspective on that a little bit.
Yeah, well, if you'll give me a little latitude to geek out for a second, I
Yes,
will.
please.
I will definitely dive in a little bit. So, um, I was fortunate when I went to AFRL because they said we want you to work in the liquid rocket engine branch, and so the thing that I immediately started to work on were like precursor technology programs for what eventually becomes engines like what Raptor is for SpaceX, and now the engine at Stoke, and then there's a couple of other companies playing with full flow. So, but to answer your question, when I got into that, I realized how little I knew and how many engineering disciplines are required to really be a good chief engineer of a liquid rocket engine program. There's like 13 different engineering disciplines required just for a turbopump on a liquid rocket engine alone. And when you talk about, pumps rotating at, 30 to 90,000 RPM, when you have combustion processes and pre-burners and gas generators that are driving turbines at super high temperatures, I'd pick out a few different things to say why it's so hard. We're still not as smart as we'd like to think we are in terms of analyzing physical processes. And even today, I mean, it's been one of those holy grails to use CFD and combustion modeling to model both a main injector that mixes the propellant and oxidizer in a thrust chamber, as well as these gas generators or pre-burners that pre-combust to drive the pumps. And those processes are so complex and so rapid that the physics is just difficult to analytically summarize correctly for design. So you still end up needing a lot of trial and error when you design both injectors as well as pumps. And so if you're a new company that's relatively junior in engineering experience, it's just hard because you're having to learn a lot of lessons that more seasoned companies have already learned. And SpaceX went through this as well in the early days, and now they have a pretty robust internal capability in both people and data, but they had to build that. And I think um, that's why you see things like the Raptor program evolve quickly and more rapidly now because they've got many years of this experience. So I think one of the reasons you still see startup companies struggle and startup launch companies struggle is because they're still building their know-how. And the second thing I would say is that there's a big difference between a development piece of hardware that shows you can design something and something that's ready to be produced that's reliable. And I think oftentimes startup companies, especially in launch, they get to an engine test or a stage test and they're advertising it like they're ready to go to orbit and they're not even close. Or if they do, and make it, can they keep doing it again? And every company struggles with this, and it's always that piece that's underestimated. Um, it's what Elon kind of refers to in production hell, right? It's like, how do you build the manufacturing processes around a design you now think works? And the thing is, you got to build enough of them to see all the edge cases for the variability in your design. And that is what makes it challenging when you have so many parts in a launch vehicle. If you still have roughly a million parts in any launch vehicle, it's a lot of opportunities for failure. And so with the liquid rocket engine part itself, it's just there's so many pieces, there's so much energy. I'd say it's one of the more difficult engineering problems outside of something like fission or fusion, where you have got to contain combustion processes happening in multiple locations at thousands of degrees Fahrenheit, and you've got to cool those metallic structures or composite structures in ways that they don't melt themselves completely down. So, you're basically containing fire, and you're going to need to do it routinely and reliably and over again. And one simple mistake ends in destruction. And one of the really interesting historical stories is when they developed the space shuttle main engine, they didn't have all the computational horsepower that we have available today. So they would build engines, they would melt down, they would rebuild them, they would melt down, they would build new components, those would fail. And it was a ton of trial and error work. And that's super expensive and time consuming. And so one of the things I've benefited from in my time working in propulsion was NASA had spearheaded a lot of computational modeling programs in the 80s and 90s to try to minimize the amount of iterations. And what that was focused on was the startup and the shutdown transients of a rocket engine, because that's when things go crazy on start or shutdown and the temperatures swing too high. You're melting things down and destroying things. And so a lot of times people don't realize that operating an engine where it wants to be is not that hard. Starting it and getting it where it wants to be and then shutting it down without destroying it are the two hardest things, especially on something that's so-called a fuel-rich stage combustion engine, or in Raptor's case, a full flow stage combustion engine. Everything's happened so fast. In the blink of an eye, you could literally have the whole engine melted down in the flame trench.
There are so many questions I want to ask here, but in the interest of time, and this is not obviously we're not doing an episode on the do's and don'ts of rocket engine building, but I do want to pivot and talk a little bit about your time at SpaceX. So how did you end up there, and what was your mandate when you first arrived?
So in about 2010, I think SpaceX was um, starting to kind of reach out because they didn't I didn't know this at the time, but the backstory was they were getting more serious about wanting to start a program that at the time was called Raptor, that later we kept that name going forward. And so in 2011, literally, I don't know that people always believe this when I say it, but I was working in Huntsville with NASA on the J2X engine for the Ares rocket program. And Elon's assistant called me at home one night and asked if I had time to chat. And then he and I talked directly for about an hour. And then that turned into two trips to Hawthorne. And then I joined shortly thereafter. And my mandate was figure out, help figure out what SpaceX is going to build. And for the next generation, what we didn't call Starship yet, but had three or four different names before Starship. But what was that engine going to be, and what technologies were required to be developed? And I was the fortunate person that got to be the first person to really corral that program and get it structured in a way that got it off on the right foot for development. So that was my mandate: is get a development engine on the stand in less than 5 years, and that's what we did. So.
Do you miss when it used to be called the Big Falcon rocket?
No, I was never a big fan of that name. You know, that sounded a little, yeah. I'll just leave it there. I wasn't always a fan of BFR, and then it was called ICT for a while,
Yep.
Colonial Transporter, and then I think it had another name before. I think it might have come back to BFR again before Starship and Booster, but. The thing is, when I look back on that, and we're talking about 10, 12 years ago, um, the things that we were talking about for what became Starship and Starship Booster are really what has materialized. So I was looking at a lot of these engine packaging studies for the bottom of the booster. We were talking about what would be the right payload to try to carry to facilitate Mars, and you know the diameters ranging from what they are on the order of 9 meters to bigger than that. So I mean, everything has stayed pretty much true to course. Even the idea of bringing it back on the tower, which everybody thought was insane, but we also were um, cautiously optimistic about landing Falcon 9 first stages too. But once you start to do that, then a lot of things seem possible, and landing back on the launch pad didn't seem so crazy anymore, which that's second only to watching the two side boosters of Falcon Heavy land next to each other for the first time at the Cape. I'd say the chopstick landing a booster is a close second, if not tied, for some of the coolest engineering that I've seen out there.
So, what was the hardest kind of technical challenge in developing Raptor, like looking back on it?
I think it was is putting the pieces in place, both with technology and engineering know-how, to do a much more complicated engine cycle. And so, pardon the vernacular, but the Merlin engine was a fantastic engine that Tom Mueller created and had evolved multiple times. Um, but it was a simpler gas generator cycle engine. It has some simpler approaches to some of the components, and a lot of heritage work that NASA had done previously to help jumpstart that program. And then, the SpaceX team really just optimized and made that thing ready to go from a cost and commercial standpoint. But the chamber pressures and the pressures in the system are lower. The combustion environments are slightly less complicated. And, you know, when you talk about now going to something where you're running two separate pumps with turbines at very high temperatures, with pre-burners, with methane. You're picking a different fuel now. You've got higher performance levels. You've got a much more powerful cycle. And then you've got metallurgy, complicated metallurgy that now you have to develop because you have an oxygen-rich combustion side of the engine and a fuel-rich side of the engine, which with Merlin, it's just, more of a fuel rich approach. So there's just a lot more design complexity. The energy levels are higher, the temperature extremes are greater. And so it required, it was fantastic that that whole SpaceX team had been cutting their teeth on Merlin and Merlin upgrades, because I don't think Raptor would have been possible if you didn't have that experience of the team. And I think one of my big jobs was to, you know, help shepherd some of the new technology for Raptor into the development program, do a ton of risk reduction up to the point of where we could get a development engine on the stand. Because my argument to Elon was always, let's get an engine on the stand as fast as possible and learn what we don't know, and then we can improve. And you've watched them continue to do that since I left the company in 2016. So
Yeah, amazing. Well, so kind of to that point, you did leave the company, and you ended up holding senior roles at a variety of different great firms. But let's just talk about two of them specifically: Stratolaunch and Commonwealth Fusion. Tell us a little bit about maybe those companies, what you were trying to build there, and why ultimately it didn't scratch the itch.
yeah, so Stratolaunch was really an interesting opportunity. I had met some people while working in Huntsville after SpaceX, and I'd gotten introduced to Paul Allen, and it was really kind of surreal because it was the same type of thing. Paul had called me in Huntsville and asked if I could come to Seattle, and you know, I was going to have like a 10-minute meeting. He wanted to talk about, bringing in engineering capability into Vulcan Aerospace and Stratolaunch, and I was ready to talk about that. And 10 minutes turned into almost 2 hours of conversation. And I think later on it was really because, you know, I came to talk about what he wanted to talk about. I wasn't there to ask him something else or ask him for money or do any of the other things people do when they visit billionaires, I suppose. And and I think that was just a really amazing program, because as we were building the hydrogen engine system we developed for two different spacecraft for Paul, he loved additive manufacturing. He loved learning more about aerospace hardware. He used to joke with me about, you know, why can't this move fast like software? It needs to go faster. And then I showed him additive manufacturing, and he's like, this is what I want to see. And so he really enjoyed watching the tech maturation of that program. And so, the only reason that program ended, I had teams in Huntsville, Alabama, and Seattle, and it was just a great time in parallel with what they were doing with the large aircraft out there in Mojave. So The only reason that ended is because unfortunately Paul passed away, and um, Paul's family wanted to take the company in a different direction. So that's kind of how that ended with Commonwealth. What a great team out there in Devon's doing some amazing things with technology. I think curiosity and I'm a big proponent of finding technical solutions to these issues with climate that we're facing. And
And Jeff, sorry,
and
before you continue,
yeah, sure.
for the sake of the audience, Commonwealth Fusion is developing a magnetic, tokamak based fusion approach to fusion energy. So just, and feel free to add more to that, but I just wanted to give some clarification there.
Yeah, I think the other thing I would say about Commonwealth Fusion Systems is, a lot of bright people, coming out of, MIT and other places that, have wanted to bring fusion out of academia and more into a practical operational capability because of the power demands in our foreseeable future. And so, their approach with a tokamak and trying to leverage superconducting magnet technology is really novel in terms of what has traditionally been done. So that was very attractive for me to learn about and see where I could make contributions from an engineering standpoint, kind of cross pollinating from aerospace into fusion, um, and ultimately. Um, there were opportunities for me to really come back to space and the industry that I started in and loved as a kid, um, and I think some of these experiences I've had since SpaceX, SpaceX at the end of my SpaceX time was really the beginning of me being able to operate as a technical executive in tech companies. And then I really wanted to broaden my experience as a technical executive just to see, is there anything I'm missing? Because the aerospace industry in the US tends to be quite myopic and insular. And, I've always tried to look beyond the industry to see what are other tech areas doing? How are they approaching problems? Um, from an engineering standpoint and then a leadership standpoint. And then lately, I've also been looking, internationally, what are people doing and how are they looking at these things? Because I think the U.S. has a tendency to be a bit too nearsighted on approach, and so that's one of the reasons why some of these tech exec experiences were so valuable to me, especially as I came back to build Portal Space Systems here recently.
Yeah, so tell us a little bit about Portal. When did the idea? Well, tell us about what it is, and then when did the idea for Portal click for you?
Sure. So Portal Space Systems, we founded the company 4 years ago with a mission to solve a problem that I was seeing where we just lack rapid maneuverability on orbit, right? We can move things around between orbits and into final orbits after a rocket launch, but it doesn't happen very quickly. And so what I tell people the problem is imagine that the US only designed airplanes that could fly at one altitude, but everybody else could fly wherever they wanted. That somewhat presents an issue from both a defensive and commercial opportunity standpoint. And so the problem we set out to solve is to build a novel type of spacecraft that wasn't as limited from a maneuverability standpoint. And that's what we did. So 4 years ago, we started Portal and we started evolving what we call our Supernova spacecraft system. It leverages a novel solar thermal propulsion system, and we built a spacecraft around it because that's really what you needed to do is rethink how spacecraft were built. And if I may, the thing that's different with what we're doing at Portal is in the industry in the U.S. and really internationally, you have companies that know how to build spacecraft buses, and you have companies that know how to make propulsion systems. And so it's really hard for these spacecraft people to develop a new maneuverability capability when they're having to still buy the same electric thrusters or monolithic or monopropellant systems or whatever. You're limited based on what's out there in industry, and so I didn't want those limitations. So I had spent a lot of my early career, helping to solve the launch problem for affordable, rapid, and more of it. And then I wanted to participate into what are we going to do with that. And so watching through the public lens, um, of these articles about the DoD really struggling with maneuvering assets on orbit, because if they move it, that's its last mission, or it's dead, or whatever. It seemed ridiculous to me. So we've developed Supernova, and we're planning to start to fly hardware next year in service to solving the rapid maneuverability problem, which means high performance and high thrust on these spacecraft systems, which presently we lack, but our adversaries don't.
So the defense use case of what you've just described is pretty clear, and we'll talk about that in just a second. But talk to me about the commercial side. Like, where is this type of capability interesting or valuable for the commercial side of the space industry?
I think there's a few areas, and they tend to always gravitate towards like in space servicing, life extension type things. But I think even the bigger short term opportunity on the commercial side is just movement into geo. I think we've seen several years now of the business case in LEO really mature, especially with commercial internet access, worldwide, and that's not slowing down. And now you have companies looking at, well, what opportunities exist if I had assets that were affordable that I could put in MEO or GEO, but then how do I get there? Because we've got great LEO launch capability, but we don't have very frequent MEO or GEO launch opportunities. So now you see some companies moving towards wanting to provide more GEO transportation options to get more stuff out there. And that's one answer to getting more things out to MEO and GEO. And the other is have spacecraft out there that can refuel and get there themselves. And so that's what we've done. So from a commercial standpoint, we can move assets or host payloads in MEO or GEO and move there rapidly to perform different missions or collect data for certain commercial applications. Those are the big near-term opportunities that we see.
Okay, and then maybe walk. You're alluding to a couple different things. Maybe walk through the architecture of the system. So you have Supernova. Maybe give us a little bit about the specs behind Supernova, and then you mentioned refueling. Is this sort of a service that you're going to look for from a third party? Are you building your own fuel depots to kind of mission extend extend the mission of your own Supernova vehicles? Give us a little sense of maybe sort of the vision for the architecture over the next 5 years.
Sure. So Supernova itself, at least the first generation, is roughly a 700 kilogram vehicle. Um, and it has about 200 newtons of thrust. And so you can, with that kind of thrust on that size of spacecraft, now you can really create the acceleration you need to move around more rapidly between, MEO to LEO in less than 3 hours. You can go MEO to GEO in a half a day. You can even go LEO to GEO in a day if you want. That type of rapid maneuverability across those three orbits just doesn't exist right now. So our architecture allows for a couple of things. You can do those types of multiples of those types of missions on one fuel tank. But then we created, an option in our architecture where we can have a tanker that allows us to top off spacecraft when they return to their strategic orbit, wherever that is. So we've always envisioned supernovas working with other supernovas, um, similar to drones and that swarm technology. We plan to apply similar approaches on orbit, and then be able to life extend our own spacecraft, because I see a lot of space companies making some mistakes where their business case doesn't close unless another company does a thing. Like Starship has to exist as one example, or somebody has to have a fuel depot ready to go, and they have to do that. And so I didn't want to be dependent upon any other company to be successful, and I didn't want to wait for other companies to have refueling on orbit. So we designed our own capability to refuel our own spacecraft until such time as maybe there's a more proliferation of gas stations in the sky, so to speak. But I think what that allows then is anytime, we see a world where our business allows us to perform more commercial missions or NASA missions or international missions. And when defense has a need, then we can quickly move those assets into wherever they're required. And we can do that in hours, whereas defense assets today, when they're tasked, might take weeks or months or never because there's not enough gas in the tank. So that's where we see our dual use capability shine. And The Space Force has a program they call CASR, which is similar to the old CRAFT program, which is like the Civil Reserve Air Fleet, where you're off flying airplanes to carry people wherever they're going, but if the military needs plane transport, it's accessible to them. We see eventually participating in that same type of model for Supernova and having multiples to do that. And you just require fewer spacecraft at higher orbits to do certain missions that require hundreds or thousands of spacecraft in low Earth orbit. And so I think that's where we really differentiate. And we're not going to be all things to all customers, right? And we don't want to be. But if somebody needs the capability to move rapidly between orbits or inclination changes to perform a commercial or a defense mission, that's where our platform really shines. If you still are okay with taking weeks or months to orbit raise to start making money, that's no problem. That's not something that I don't need to compete with. But if you want to dramatically reduce the time you get to your final destination to make money, which I don't know anybody that wouldn't want to do that, I think the rapid nature of this movement is going to be compelling. And that's really what we're providing in terms of capability. And the other thing I'll mention is we built a lot of payload flexibility into our system because using a tired metaphor, I really did want to be like an iPhone of a spacecraft, right? I'm not going to envision all the payloads and apps everybody wants to use, especially my defense customers that may have classified missions. I don't need to know that. What they need to know is here's what this spacecraft can do, and then they can decide is that something they need to perform a certain mission set. And then we've seen a lot of partners come to us in the last 6 months that are focused on these exquisite payloads for commercial and defense applications, and they're looking for a spacecraft to fly on. So that was another predict the future moment where I was hoping if we just stayed focused on developing the best possible spacecraft we could for rapid maneuverability, these payloads would start to materialize. And then I think we're starting to see that in the industry right now.
To the extent that you can share, how do you think about pricing?
Well, that's an interesting question. Obviously, we don't talk publicly right now a lot about our pricing, and we're still, in development as we get ready to fly next year. But I think I saw a great article yesterday from an author at Space News, and he was talking about, you know, essentially all these big promises every company makes, and when you really get a chance to peer behind the curtain, you know, everybody's over promising and under delivering. And it's kind of been a hallmark of the aerospace industry for the whole 30 years I've been in it, right? And the problem is people think they've got to really lower targets and lower pricing to entice a customer to say yes. And then that leads them down a path where then they're disappointing that customer in the future because it's always costing more, it always takes longer. This is like everybody, small, medium, and large size businesses. This is how they all go. Even SpaceX, they delivered and we delivered on price and capability, but we rarely delivered on schedule, right? You never get something for everything. And I think when you start to think about pricing specifically, I think you need to understand where you are with your business and be in lockstep with your customers' needs and make sure that you set that pricing model in a way that sustains what your customers are demanding on contract. And so I really like the things that we did while I was at SpaceX in terms of being able to work more nimbly with customers and then you know set that pricing at a place where it's a huge cost savings over what's happening now, but it's not putting the business in a weakened position. So I know that's probably a unsatisfactory answer to your question, but I think those are the problems I see in pricing is you've got to know enough about your business to know what it's going to take to sustain it in a fair way. But I think if you're working on a hardware product for a customer, you need to be giving them a massive benefit compared to what they're paying the primes right now to perform some of these missions. And so that's how we looked at both what drove our design, which would lead to some of the pricing models where we really want to give our customers, you know, an order of magnitude or more in price type of reduction. That's what they really want to see. But I think what happens is businesses promise that too soon and then they just can't deliver it. And they need to spend more time developing and proving that that's possible before they lean quite so hard into like it being a real thing.
Well, the pricing question is always wishful thinking. So I appreciate the detail you've given me anyway. And maybe next time you're on the show, we can talk more about it. But
Absolutely.
let's talk about let's talk about something I know you love talking about, which is propulsion. Talk about why the decision to do solar thermal propulsion, and what does that even mean?
Yeah, I think it started out with I left SpaceX, and a few months later, I had some folks at Lawrence Livermore call me, and they said, "Hey, we're talking about propulsion, future of propulsion here. Based on your background, we'd love for you to come and talk about what you think the future of propulsion is in the United States or the world or whatever." They kind of left it open ended. And so this kicked off a mental exercise for me to really dig in and decide for myself, what do I really think the next big thing is? And what would I want to work on for the, rest of my career? And it comes down to nuclear thermal propulsion for me. If we really want to extend human presence in the solar system, we've got to move faster, and we have a technology that can do that for us. But nuclear has been a four-letter word forever, ever since end of World War II, and that creates a lot of fear and superstition and cost and things that have really held us back on developing both fission and now fusion, I think. So nuclear thermal to me was going to be the future. So I started looking at spacecraft designs in 2016, 2017 on my own free time on how I would put that together. And while I was doing that, was looking at some of the work that had been done with solar thermal. And I really liked thermal engine cycles if you can make them work, because you're not carrying oxidizer, you don't have all these complicated combustion processes. It really becomes a simpler, more benign form of propulsion. Unfortunately, I couldn't go buy fission reactors at Lowe's yet. And even if I could, there are not enough of them being produced a year, with the kind of numbers that we want to start producing Supernova in 27. So solar thermal became a real interesting technology that was really a lot of risk reduction performed by NASA and the Air Force in the 1990s. And, kind of picking up some of that work that the Air Force Research Lab and NASA did, bringing in additive manufacturing, some new advancements in alloys, um, some partnerships on some of these spacecraft structures, like the mirrors that we use as part of that system for our particular spacecraft. All of that was at a much more mature state than it was in the 90s, and so that's kind of how that design concept evolved. And eventually, I'm still a big fan and want to enable nuclear thermal propulsion. But the biggest obstacle of that is really political, allowing us to finish the technical development of that. But when somebody has a reactor ready to fly, I'm going to have a spacecraft ready to facilitate that. And that really was what was the beginnings 4 years ago that led us to a go-to-market strategy with Supernova, with the technology we had in hand now, and could finish, developing and risk reducing for flight over the last 4 years.
So the spacecraft architecture of Supernova will allow you to plug and play some type of reactor technology in the future. Is that kind of what I'm hearing?
That's
Okay.
what you're hearing. Yes.
And what comes after Supernova? Is there sort of a roadmap, or are you just kind of focused on Supernova for the time being? Because there is, and let me give you some more kind of thoughts on this, which is there is a school of thought, of course, which I would wager that you agree with, which is that Starship is ushering in a new and kind of pretty significant paradigm shift in engineering practices, as to how companies build and build for space. And one of those potential kind of outcomes of all this is that building bigger and cheaper could be an outcome, and not so much exquisite. So is this part of your thought process as well, or do you disagree? How do you kind of think about that sort of post Starship world?
I agree with you. I'd say where I disagree with maybe others is I want to be able to be ready to take advantage of Starship when it's there, but I didn't want to be limited in what I was doing until Starship exists. So what I see is, we picked the size of spacecraft we could develop and prove out to our customers at the lowest, development cost with the smallest team, right? I'm minimizing capital expenditure to get technology working that solves a mission for my defense customers and commercial needs and NASA first. And then to your point, I will scale that to larger and larger payloads because, right now we can deliver 4 to 6 kilometers a second at delta V with our Gen 1 Supernova system, but that's with a relatively small payload because I've only got a 700 kilogram spacecraft, right? So there's a lot of customers out there that have larger and larger payloads, and we have plans to scale Supernova and take advantage of this larger launch capability at a much reduced cost should the pricing come to fruition that's been advertised for Starship. So absolutely, we tie into that. Um, and there's actually even for Supernova Gen 1 with vehicles like New Glenn and Starship, the fact that we could launch, multiples of our spacecraft on orbit. And I'm not going to be creating a 3 or 7,000, 10,000 spacecraft constellation, but I'm going to have multiples of these in strategic orbits to do certain things. And I think all of what's happening with New Glenn and Starship facilitates that for our current generation of vehicles. And then, some of these scaled versions of Supernova that we have planned, certainly Starship will help facilitate. And then beyond that, I think is the nuclear thermal version of this spacecraft that really was the first idea we had when we started this company, um, but really knew we needed to take this intermediate step with solar thermal first.
Tell us a little bit about your kind of customer traction so far. I mean, you alluded a bit to Space Force, DoD, to the extent that you can share. What does that kind of current customer base look like? And then you mentioned next year, I think you said, where you'll see Supernova fly. Any kind of clarity around when next year, kind of early, mid, late next year?
If I take 2 steps back, when one of my co-founders and I started Portal 4 years ago, we made the decision to spend the first 2 years just doing customer discovery and understanding the customer problem because too many space companies are working on things they think are cool that nobody cares about. And that's not a business. And so I didn't want to start dumping tons of venture capital or our own money or our angel investor money that we started with into anything that wasn't aligned with what we believed the customer need was. But I wanted to go confirm that. So we were fortunate to work with some folks in the early days that plugged us into over 60 different entities within Space Force and DoD and the IC community, intelligence community, just to say, hey, this is where we're headed. You know, if you think it's dumb, tell us it's dumb. If you want something else, tell us what that might look like. You have an opportunity to influence the design here, and it won't cost you a thing. And and because I'm a veteran of the Air Force, and we have other veterans in the company, you know, we're already philosophically aligned with helping out the defense industry if we can be helpful. And we wanted to be a different kind of partner where we're not coming to sell you something you don't need just because we've made it. We want to give you something that solves a problem and can do that at a much better price point. And so, because we went through that exercise the first 2 years of the business, I think that's why we started seeing success a couple of years ago with the SBIR program, with phase 1 and phase 2 contracts, and then being selected for a StratFi contract late last year. And then really just focused 100% on the warfighting operational community. I mean, our friends within the acquisition community are also doing a great job, and there's a tremendous load on those folks to facilitate what the country needs right now. But I wanted to make sure that we were providing something the warfighter was excited about because these technologies are directly applicable to so many commercial and NASA and science missions. I don't worry about that at all. But defense always leads in space, in my opinion. And I wanted to have a solid connection with the DoD, partly because I'm a veteran of the Air Force, and partly because I see our adversaries moving in front of us in some of these in orbit activities right now. So I was pretty passionate about that. That's nothing to do with a profit motive. And I think that's what makes a difference. And I've tried to really convince our government customers that that's where I'm coming from. And I think at first, they kind of saw us as just another startup space company. And yeah, we'll see. And I would like to think that we've continued to do the things we've said we'd do. And I keep coming back to them with updates and progress and things that, are going to deliver capabilities that they require. And a lot of these agencies are stepping forward to really be super supportive of what we're doing. And I've been really excited about that on the defense side per se. And I think as that unfolds, then you start to get more of the commercial, international, and NASA because they always wait for defense to kind of de-risk things anyway. But it's really been a tricky environment, Mo, because um, ever since SpaceX came on the scene, the government really likes companies that'll go get a bunch of venture capital and de-risk a product and just bring the product with no government investment. And not every company has varying degrees in which to make that happen. And I've been criticized at different times because I think people thought I should go raise more money sooner. But I didn't want to go raise a bunch of venture capital money and then waste it trying to figure out what the customer wanted. I wanted to find out what does the customer want now and then go show that to investors, show the traction, and then be super capital efficient with every dollar that we bring into the business. And I'd like to think that we differentiate ourselves a little bit that way.
How do you well, yeah, let's talk a little bit about competition. There's two companies that come to mind in particular, mainly because they've raised quite a substantial amount of capital. One being, a company that kind of positions themselves almost as a space defense prime, and one who happens to have your same alma mater, we've mentioned already, and who obviously shares a similar level of experience as you do. So maybe tell us about how you kind of think about positioning your business versus competitors.
Yeah, I mean, I don't feel like there's anybody doing quite like what we're doing. I didn't think that 4 years ago, and I don't think that now. Um, I mean, our technology is unique. The capability is going to be unique for rapid maneuverability. Um, but I think there's space for everybody to play, right? I think often when we get compared to other companies, um, it's because they're self-modeling, transportation services to somewhere or whatever, and we're not really. We could perform a tug-like mission, but our goal in life is not to move stuff from orbit to orbit. Um, our biggest business won't be moving things from probably LEO to GEO, even though we can perform that mission. It's going to be customers that need to move payloads fast from one place to another to perform a certain thing. And that can't wait on a launch vehicle. So a lot of companies leverage launch vehicles to perform a transportation mission or whatever. And I'm happy to participate in rapid launch if somebody wants to have a bunch of supernovas in a warehouse ready to go, because we can swap payload suites at the last minute with our flexible payload deck and software definable power. But what's better is having multiple supernovas in a strategic orbit, and then a need pops up, and I can be there in a few hours. I'm not waiting to be integrated with a launch vehicle. I'm not waiting on the weather at the launch site. I'm not waiting on the launch vehicle can't get me quite in the right orbit, and then I got to make an adjustment to get to the final place. I mean, so that's unique to us. Whereas I think other companies are um, solving the problems a little bit differently, but I don't see a lot of new things from a technology standpoint. A lot of people are using like high delta V now. Everybody wants to say they're high delta V because the DoD has put emphasis on that, but that's only half the equation. Delta V just means you've got more range. You can perform go more distance, but without a high thrust capability, you're not getting there any faster. And so anyway, I think we've combined the two into a very self-contained package that can refuel itself in strategic orbits, which is very different than some of the other architectures that I think we get lumped into those buckets of competition at different times. And frankly, even if you look at a company like Impulse Space that is providing more geo transportation with Helios, I think it's great. I would love to fly supernovas on Helios to geo to save gas when it makes sense. Um, but at the same time, I can move between those orbits without that, and that's the kind of flexibility I want to give our defense and commercial customers. Is you don't require a thing; you've got multiple ways to get your mission accomplished, and that's why we kind of compare Supernova to like an F-35 multi-role kind of fighter of space, in that you've got lots of options.
What are you going to be pursuing any type of additional financing prior to kind of first launch of Supernova?
Well, we are going to start launching hardware in orbit next year before we do any additional financing. To answer one of your
Okay,
questions,
got it.
we do have plans for future funding rounds. We just completed our seed round, as you know, $18 million seed round, and so um, got a great group of investors and partners that have come along for the journey that I'm very excited about having joined the team. And then we've got a risk reduction flight of a lot of our avionics and flight computer and some of our critical sensors in February of next year. And then we have another risk reduction flight that we'll say more about in the coming months that'll happen in Q4 next year. So we have two opportunities for flights to de-risk Supernova, and I think that's really this is Portal's answer to our partners in the defense community that really need to have systems work. And so I've watched a lot of hardware fail like they have over the last 3 or 4 years. And we've tried to craft a development program based on, my past 30 years of experience and other people I have on my team where we're going to keep showing them that this stuff is working and Supernova is going to come online near the end of 26 and the first part of 27 right now. But that's what the future looks like for us and kind of where we are. But we don't quite require any additional fundraising to fly these missions next year, which is super exciting for my team. And then we actually are also in the beginning stages of uh, expanding our footprint so that we can put ourselves in a position to manufacture multiple Supernova spacecraft a year here by 2027, which is also exciting.
Amazing. What excites you the most of where Portal could be over the next decade?
I guess I'm most excited about, I guess, first, solving this defense problem that troubles them so much and that they don't have enough rapidly maneuverable spacecraft. So I'm going to be thrilled to see the look on their faces when finally somebody gives them the thing that they really wanted so bad to solve the last several years of angst in moving spacecraft assets. That's probably the first thing I'm excited about. Um, and then how that translates to my team, seeing them help solve that customer need and have that customer be super excited about that. But while we're doing that, I think equally as exciting is bringing a new type of spacecraft with technologies that are different, that unlock not just maneuverability for defense purposes, but now facilitating more experimentation in the cislunar domain and through the Van Allen belts and um, supporting the footprint of humans out to the moon. I think those are even more interesting things. I mean, I'm a firm believer in protecting and defending space for the future free use of the US and their allies, right? So we have to do that first. But what I'm even more excited about is probably some of these exploration capabilities that our technology will be able to help facilitate. And then beyond that, the advent of um, affordable and accessible fission power for space that will allow us to even push further beyond the Earth Moon system. So I'm really excited about unlocking a spacecraft capability for the Earth Moon system and then being able to upgrade it over the next 5 to 10 years and really push us beyond the Earth Moon into the solar system. I decided a long time ago that uh, when I was at SpaceX and finished my time there, I got to do everything I thought I wanted to do in my entire career. So I went through this weird thought process of took 2 years about after I left SpaceX of what am I going to do next? And what I decided I wanted to do next is really make a significant contribution to human expansion in the solar system. And along the way, I think I feel compelled to help DoD protect and defend that opportunity for the free world to do that first, and then get after it with these larger systems and more capability and taking advantage of Starship and all the things we talked about today. So that's what I find to be super exciting. And then I guess I'll leave you with one last thing that's maybe a surprise, which is the thing I enjoy equally among all of that is taking a team that loves to solve hard problems, but they're not sure we'll get there. And then we get there and watching how they react to that success and how that unlock lets them unlock even more of their potential. And we're already seeing that within the team, and we'll keep seeing that. But I think as a business leader, as a CEO, as a mentor or coach, that's one of the most exciting things, even with all of the space tech stuff, that when you help people unlock a new level of performance, um, I find that personally satisfying because I think there's too many people out there that think you have to whip and beat people and threaten them to get them to perform. And I just don't subscribe to that philosophy because I've been able to take teams to equivalent or better levels of performance by taking a different leadership approach. And I think that excites me just as much as fielding the tech on orbit does.
Well, I will say, and I don't want to jinx it, but you've sort of already set up yourself to have made a significant impact on exploration and beyond, moving beyond the moon with your work on Starship and Raptor. But obviously, you're getting a chance to double down now. So, but I have to ask, since I have you here, just to kind of wrap up. Starship has had a complex year, to say the least. What is your perspective on the development so far? Some of the issues with the vehicle, and kind of where do you see that going? As someone who was, who's kind of instrumental to the beginnings.
Yeah, there was never a more exciting time than those years I was at SpaceX, and I'm forever grateful to have done that. I would tell people, and I've been asked this question a lot lately, especially after the recent development test of Starship and that failure. When we started in the early days, and when NASA was developing things for the moon program, we did those in test areas that were segregated from public view, right? There were buffer zones and fencing, and people weren't camped out with telephoto lenses and video cameras watching every single thing that we did. And in the early days in the 1950s and 60s with NASA, they blew up and tore up a ton of stuff that the public wasn't paying attention to or has forgotten. Um, ULA and their predecessors and SpaceX, especially in the early days of Falcon 1 and Falcon 9, there was plenty of failures that occurred, some of which the company, the public has no knowledge of or has forgotten about. So I think Starship and Starship Booster are unique in that SpaceX has been brave enough to do this level of development squarely in the public eye with multiple websites and influencers basically ringing the fence line with cameras on everything that they do. And I wouldn't pay too much attention to that right now because the one thing SpaceX and other SpaceX derived companies do well is learn from the failures. And that's kind of intrinsic into the culture is it's okay to fail, but make sure we got the data to know how not to have that failure again. And I think it's complicated. Space is hard, as they say, but I say that with a caveat in that from outward appearances, it looks like the same things are happening, but I don't believe that's necessarily the case. I think you've got a lot of rapid iteration happening, which SpaceX does pretty well. And the mantra really is fail as fast as you need to get to the end state more quickly and understand what the margins are. See, a lot of people don't understand that a lot of things that NASA and the government have built in the past, they had to be perfect the first time. So they were probably carrying a little extra weight. They had extra margins because they couldn't afford any failure or the government would cancel the program. Where SpaceX has a different philosophy where we don't want to carry a bunch of extra weight and extra fuel if we don't have to. So let's go figure out exactly how much margin we have in design. And that's probably going to mean we're going to have to fail some stuff to figure that out. And so it looks very spectacular on film, but in the end, you end up with a more robust product. And I don't think it gets any better than the example of what was it, the 500th flight of Falcon 9 the other day, successfully, something like that. I mean, arguably the not only the most advanced but the most reliable medium lift rocket ever produced ever. So I have a high level of confidence in that organization at the team. It's tough when you're in the middle of development. There's a lot of stress. Um, you don't want to have that on the public view, but that's the path they're on, and it makes it a little harder for them. But I don't think it means they're behind. I just think it means we've got more insight into the sausage making, as they say, of the development process.
Well said, Jeff. Thanks so much for that, and really appreciate you coming on to the show. This is great, and looking forward to following along the progress and the milestones for Portal over the next year.
Thanks, Mo. It's really been a privilege to be with you talking about all things space and portal today, and I look forward to chatting with you again in the future.
Until next time.